Okay, so this is actually the mathematics behind exponential decay. And there's more on this page than there would be normally because I give you the 4 different, it's called a logarithm or natural log, ln. And what it does is it takes the exponent from where it is, okay, and it brings it down here. It's like an anti-exponent or an unexponent. It's the inverse of the exponent, kind of like subtraction is the inverse of addition, and division is the inverse of multiplication. The square root is the inverse of squaring, you know. So taking the logarithm is the inverse of taking the exponential. Does that make sense? So once you learn these rules, it's really easy. So this is basically the distributive property, but the plus sign goes there. Okay, distribute plus sign. And then I said guess. What happens if you're dividing them? I'm going to let you guess. And then here, this is the reciprocal rule. And then this is showing you that process of bringing the exponent down. And then I kind of go into that a little bit. And then we go up here, and this is actually our data. Situation 1 where we said only 15 died because they said only 15 of the 20 birds that died had H5N1 in their bloodstream or in their body. But 20 birds died. So I say, well, let's go with 20. And so first thing we do is compute the rate of change. Like what changed? Well, I said, remember, it's new minus old over old times 100. So new minus old over old times 100. And you just plug it in. And this is almost the same thing as the rate of decay. Okay, let's go down here. I continue right here. 1 minus r. So we're looking like it's, I'm using, that's for 15. This is for 20. Okay, so I'm using that number here. Okay, but as a decimal. You take that away from 1 and you get 0.9552 or 95.52%, right? And that's the rate of decay. So that's like negative. Yeah? And here you go. The future value is 0. Starting at 446, decaying at this rate, how many years will it take? Well, first, let's distribute a natural log to both pairs. And then we get log of 446 plus log of 0.9552 raised to the x. And then we subtract ln of 446 from both sides. Divide everything by, you know, when you take this log, it comes down. And then you can divide out this here. And you get x by itself. These are computational. You put these in a calculator, come up with this, and then you get this. 133 years until they're all dead at 3%, or whatever I said, 4.48%. Okay, that's it.